Hi there, Nick here, M0NTV, and welcome back to my shack and to another homebrew video. And to one I never thought I'd ever make, because it's about something I never thought I'd ever build, which is an all analog direct conversion receiver. Now, I've built plenty of direct conversion receivers before. In fact, I've done a talk many times to different amateur radio groups over Zoom over the last couple of years. But whenever I've built them before, it's the VFO. That's the thing. I've always used a digital VFO. I've always had, it's usually an Arduino with an SI5351 phase lock loop signal generator module, LCD screen, rotary encoder, you know, all the usual kind of stuff. And it works very well. But when I'm talking to beginners about this stuff, you can see sometimes their heart sinks, or they glaze over a bit and think, oh, I can't be doing all that microprocessor stuff. And if you've never had a go at that, it can be a bit of a steep learning curve. So what attracted me about this was the idea of doing something that was simpler and that worked. And the issue with using an analog VFO is that, and it can be done, and there's plenty of people that build good, stable analog VFOs, but it's hard work. It's by no means simple, and you have to work hard, I think, to do it. And all the analog VFOs I've built, and I built a few when I first started out, were all different shades of terrible, really. I mean, some were just more terrible than others in terms of their frequency stability. But the game changer, of course, is, and you'll need to go and watch my last video to find out more about this, is this Glue Stick permeability tuned oscillator. So what I've done from the last video, I've rebuilt it. I'll bring you up to speed on the latest incarnation of the Glue Stick PTO at the minute. So I'm using this variable inductance controlled oscillator to actually take part in a real radio and to be the guts of a real radio. So let me just bring you up to speed with what I've done since the last video on the Glue Stick PTO. Okay, well, I've come into the kitchen because the light's a bit better in here. So this is the third of incarnation of the Glue Stick PTO. All this circuitry is almost identical, apart from the parallel capacitance. I have to keep swapping that every time I change the glue stick. But this is the third Glue Stick variable inductor, and you'll remember the last one had 16 turns. It had two T50-6 yellow toroids glued to the base plate that's screwed in and out, and I've got about 300 kilohertz of tuning range, which on the one hand was good, on the other hand in practice wasn't so good, because it made the tuning very, very picky, and just one slight little millimeter movement and you were kilohertz out. So I needed to reduce that tuning range. So this one has got 15 turns on the coil there, and so it's got 15 turns, tapped after 4 as usual, but inside on the base plate is just one FT5043. So I used a ferrite toroid this time. That has reduced the tuning range, so I've got about, just over 200, which is fine. It's slightly offset from the bottom of the 40 meter band, so I think I can get down to 7.020 and then up beyond the end of the 40 meter band, the UK allocation at least, 7.2. But that's, for my purposes, that's absolutely fine. And this seems to work very well. The tuning is tighter. I guess that's just, one of the things about using these glue sticks. Some of them are just built more securely than others. But essentially it's exactly the same. I use 2 cable ties to hold the end windings in there. So I'm quite pleased with that. So I think that's certainly the best one that I've built. I had to, of course, because I was changing the native inductance of the coil. I had to change the parallel capacitance. So I think now, last time it was 75 picofarads, I'm up to 86.8 picofarads, and yes, I mean, I could probably faff around with that and try and get it even better and get right down to the bottom of the band, but you know, life's a bit too short. So yeah, so I was pleased with that. So that's what it looks like, yeah, that's the third incarnation. So I'm dedicating this video to Bill Meara, N2CQR, because he gave me the auspicious task of spearheading some of these glue stick experiments, and so you know, not wanting to let the grass grow under my feet, I thought, well, it'd be good if I could actually put it into, you know, a real radio and see how it fares, and surprisingly well, it turns out. But the other thing, why I think Bill might like this as well, is that this direct conversion receiver that I'm going to show you that I've built, it's very simple. It's all analog, but not only is it all analog, but it's all discrete components. So there's no ICs in this at all. It's all transistors. So if you want to trace the signal going through, it's a bit easier to do than it is with ICs. So there it is, and I never thought I'd be building one or doing a video about one, but hey, there we go. So let me first of all just show you the basic building block if you've never built a direct conversion receiver before, just so you know what's going on, and then I'll show you mine. So a direct conversion receiver is about as simple radio for receiving SSB signals as you can get. So essentially, you start off with your RF coming in from your antenna, which goes into a bandpass filter for the band that you want to use. In my case, 40 meters. That then feeds into a product detector, which is a mixer. It's just a mixer which is mixing down to baseband, to audio. And of course, a mixer is a 3-port device, has 2 inputs and 1 output. So one of the inputs is your RF signal from your bandpass filter. The other one is the input from the local oscillator. And in my case, this will be my Glue Stick PTO. And then the product we're detecting is an audio signal, which we will then feed through into an audio amplifier, and then finally out to the loudspeaker. So that's it. Right, well, the direct conversion receiver begins, of course, with an RF coming into a band pass filter. I'm going to say nothing more about them. I've done more videos about filters than it's probably ever healthy. So have a look at the one I did on the dark art of the bandpass filter if you're interested about making one of those. So obviously a 40 meter bandpass filter, we'll come back to that speaker in a moment, which comes in to our mixer, our product detector, a different design. This one is by the living legend that is Mr. N6QW Pete Giuliano, and this comes from his simple Seaver SSB transceiver design, which you can find on his webpage, one of his web pages, and we'll have a look at that. Interesting thing about this is it uses 2 J310 JFETs together as though they were a dual gate MOSFET. So I was interested to try that because I've never done that before. So we'll have a look at that. And then, so that's fed from the RF from the bandpass filter, goes into there. It's also fed, of course, by the Glue Stick PTO. And then the product that is detected is the audio signal, which comes over to our audio amplifier, which again is a very different design than I've tried before. This one, ignore that red audio transformer, that's not actually in circuit, that was just an experiment. This is a circuit which was published a few years ago now in Sprat as a generic audio amplifier. And it essentially uses 4 transistors, two 2N3904 NPN transistors and two 2N3906 PNP transistors. And we'll look at the schematic for that as well. And that drives then an 8 ohm speaker, which is over here, which is just my little 8 ohm speaker there that I got from a junk sale at our local club a few years ago. And that's it. Very, very simple. So we'll have a little look at the schematics then for the mixer and for the audio amplifier, and then we'll try it out and you can see how it sounds. So here is the schematic for the mixer, the product Detector. And as I said before, this is one of Pete's designs from his simple Seaver, and it uses 2 J310 FETs together as though they were one dual gate MOSFET, because dual gate MOSFETs are pretty unobtainium these days, unless you're going to use the surface mount variety. Now it runs at 12 volts. I actually run it at 9. In fact, I run the whole radio at 9 volt. Every module gets 9 volts. And the whole thing only draws 30 milliamps. So 9 volts, 30 milliamps, you could probably get away with using a 9 volt battery, at least for a while. I haven't really tried that. So there's a bit of filtering on the power supply. The VFO comes in here to the top MOSFET through the gate. Now the RF comes in here to the bottom MOSFET to the gate. And because the very high input impedance, colossally high input impedance that the gate sees, this 2.2k resistor to ground, because that's in parallel with the impedance here, what you're actually finding is that this 2.2 defines the input impedance. So that's effectively what the input impedance is that the RF will see. So what Pete did in his design is he included a simple transformer which essentially takes 50 ohms from your RF in to 2.2 kilo ohms here, and that works out at 20 turns on this side and 3 turns on this side on an FT 3743. And on the output, this bit here is an audio filter basically, which just filters out any RF so that you're only getting your audio signal that you want out the other end. And then that then goes out then into the audio amplifier. And so we'll have a look at that next. And here is the schematic for the generic audio amplifier. It comes from Sprat edition number 129, and it's designed by Dieter Genzo, W8DIZ, and he comments in the article in Sprat that he reckons the performance of this lies somewhere between using an LM386 and an LM380. And that's quite a bold claim, but yeah, I mean, it does work very well. Just to say, again, I don't run it at 12 volts, I run it at 9, and this R2, which is 100 ohms, I replace that with a 5k potentiometer, but I've got it wired in just 2 of the pins, so it's wired as a variable resistor, not a voltage divider. And so that means I can just vary that. So yes, I can get 100, I can get less than 100, and you'll get a bit more gain. But also I can increase that and effectively turn the volume down. Well, I played around with some different values, but that seems to work the best. What it is, it's these 4 transistors. So you've first of all got a pairing of a 2N3904 and a 2N3906, and these two effectively form an audio preamp, which then feeds into these two, and it's another 3904 and 3906. Only these are operating as a complementary pair in a push-pull configuration. So one of them is on always, and that gives us much more current, effectively, enough to drive an 8 ohm load. It won't work with a 4 ohm load. I did try it. It doesn't like that. But it works absolutely fine with an 8 ohm load. And yeah, sounds pretty good, and has a fair old bit of gain as well, which is good really in a direct conversion receiver, because this is really the only place that you really get any substantial gain. So there it is. Okay, so this was a bit of an experiment, but I just had to try it really. So I've got almost the same setup as you saw before. So got the PTO connected, drawing about 30 milliamps as usual, except that I've disconnected the the speaker here, and you'll see I've got another audio cable connected into that audio output, and that, if I just follow it, ignoring all the graveyard of other projects going on here, going over here, and it comes into finally into this, and this is a little Behringer external audio interface, and that it connects via USB to my Mac, and get a load of this. Yeah, I'm decoding FT8 on a Glue Stick PTO. Unbelievable. And I'm going to do a screen capture now, so you'll see this in more detail, but I just had to try it, but absolutely amazing. So you can see on my Mac I'm running WSJTX, and I've also got a browser running down the bottom left, and I'm on the PSK Reporter website, and you can see I've got it set up to show all the messages I'm decoding. That's the best one, I think. Asiatic Russia. Yeah, so that's a good old way away, but yeah, plenty of stations across Europe. And you'll see, I mean, look at that waterfall. I mean, of course there's some drift, and that's evidenced if you look at the right-hand column. You can see that same G0 signal. I'm decoding it, but there's a little bit of drift. I've got it at 1790, then I've got it at 1788, and in a minute you'll see it's 1787. But that's only 3 hertz. I mean, that's quite incredible, really. And, you know, would you use it to decode FT8? No, of course you wouldn't if you wanted to do FT8. There's far simpler ways to do it. Even if you wanted to take an analog route, you know, you'd use a crystal oscillator or something. But I just do it just to make the point about, you know, how stable this thing actually is, that it will even decode it. Now, I'd let the PTO run for a little while so it was warmed up and it settled down. And it does settle down remarkably well. But you can see from the PSK Reporter map down the bottom there that, you know, I am decoding FT8, and it's really quite remarkable that you can get that level of frequency stability with a variable inductor built on a glue stick. So, and it just kind of makes you realise that, you know, if you can do this, then really SSB shouldn't be too much trouble. But yeah, there it is. Who would have ever thought? You know, glue sticks, is there nothing they can't do? Well, there it is. FT8 on a glue stick. I mean, what's the world coming to? but I hope you found that of interest, and I hope maybe I might have inspired a few people to have a go at building their own all-analog direct conversion receiver. I'll put some links to the schematics and a few other bits and pieces down below, so you can check those out. But thank you ever so much for watching. Really appreciate it. And until next time, look after yourselves. Take care. Bye-bye.